empirical rule. We were talking about measures of dispersion. So yesterday it was range, which is highest minus lowest. Standard deviation, which is that big complex formula. We have to make a whole table if we want to evaluate. Or you can use the calculator, and it's either the sigma or the S, depending on if it's a population or a sample. And then variance, which is just your standard deviation squared. All right, and remember, we're not memorizing this. It's all on this formula sheet. So the next thing on the formula sheet, it's really nice. It gives you the empirical rule word for word. So this whole big thing is all on this formula sheet. The empirical rule only works if you have bell-shaped data. So if it's skewed, this is out the window. But if we have bell-shaped data, then approximately 68% of the points would fall within one standard deviation of the mean. Okay, so if you think about the center is our mean, our mu is right here. One standard deviation. So for instance, if my mean were, let's pretend like the mean were 25 and our standard deviation was 2. So 25 is the center point. And so if you add one standard deviation, that would be 27. If you subtract one standard deviation, that would be 23. So if you went to your original data and counted how many of your values were between 23 and 27, you would have approximately 68% of your points. Okay, that means 34% would be below, 34% would be above. That's one standard deviation. Okay, do we understand that, what I mean by that? So the next point, if you're looking on your formula sheet, 95% lies within 2 standard deviations. So a second standard deviation. So if I add another 2, 29, subtract another 2, 21. So it's saying between 21 and 29, I would have 95% of my points. So 95% of the values in my original data would fall in that window. And then 99.7 is going to be within that third standard deviation. So that would be like between 31 and 19. All right, so this only applies if our data is bell-shaped. I'm going to go ahead and give you, I'm going to do some examples, and I think I've printed a blank one of these little graphs on there. But I have noticed in the past, like for homework questions, some people don't need to draw a picture, but some people really do. So I just printed a bunch of these blank ones. So anytime you have an empirical rule problem, if you need to kind of fill things in on this, you'll have a whole set of them. So I want to give everybody a stack of those. So that is 100% if it helps you. If not, you have some scratch paper. So, this problem tells me the following data represent cholesterol for 54 patients. Alright, so here's the points. This is our histogram if we made it. Is it perfectly bell-shaped? No. Is it somewhat bell-shaped? Yeah. Yes. Okay, so part A. Determine the percentage of all patients that have a cholesterol within 3 standard deviations of the mean according to the empirical rule. So this is not for my actual data. It's saying, what does the empirical rule tell me? So we're looking, this is approximately bell-shaped. Not perfect, but real life data rarely is going to be perfect. So, empirical rule says 3 standard deviations. What percent should I get? 99.7. 99.7. Alright. Determine the percentage of patients that have the cholesterol between 34 and 69.1 according to the empirical rule. Okay, if I'm going to do this, what am I going to have to know about my data? The mean and standard deviation. And I didn't give you either of those, so how am I going to get them? Go to your calculator. We're going to enter all 54 of these into our L1. Okay, so everybody grab a calculator. Let's try it. So let's see if we agree now. Mean 57.407. For the sake of nice numbers, can we do 57.4? And standard deviation, since it said this was all 54 female patients, we'll go with the sigma. So that's 11.696. So can we say 11.7? Okay. So if we think about this, the mean is the middle, 57.4. Standard deviation was 11.7. So to get the one standard deviation, you do your mean plus your standard deviation and your mean minus your standard deviation. Let's go ahead and fill in this whole table so we can see. So the second standard deviation, we would just add and subtract it again. So you're adding your standard deviation again and subtracting it again. And then third standard deviation, we do it one final time. Now this isn't the only way to figure it out. Some people can just think about these, but this seems to be very helpful. Alright, does everyone understand how I filled in and got those numbers on my bell curve here? So, if we want between, what was it?
34 and 69.1.
34 and 69.1. I'm asking from here to here. Okay, that's not even a set 1 or 2 standard deviations, is it? Okay, so let's think about what the empirical rule says. It says 68% is within that first standard deviation. So 68% is here. You divide that in half because half above and below. Each of these little rectangles represents a 34%. How much is in the second standard deviation? 95. So, okay, so 95 minus the 68 that we already have. So that tells us each of these would be 13.5. And these percentages are always the same. All right, the third is 99.7. So 99.7 minus the 95 we already had. Divide that by 2.
2.35.
So each of these is 2.35. So then if I ask between 34 and 69.1, I can just add up my percentages. 13.5 plus 34 plus 34.
81.5.
81. Okay, so a lot of times we're just talking about a set number of standard deviations, but sometimes when I have maybe 1 standard deviation above and 2 below, that's why I gave you that paper with all those graphs, so you could kind of write on them and fill it in. All right, the next question. The actual percentage that had a cholesterol between 34 and 69.1. So let's see how accurate we are. So I want you to go through, find a percentage. We have to divide it by our 54. I want you to count how many of these numbers were between 34 and 69.1. Okay, so how many of our original points fell in that window between 34 and 69.1? did you get?
83.3.
So 45 of the points were in that window. And if you divide it, 83.3. So empirical rule predicted 81.5 and we had 83.3. So it was pretty good. Remember, empirical rule is approximate. It doesn't say exactly 68%. It says approximately. And the reason, why wasn't our percentage the same as the empirical rule? Was our original data perfect?
No.
No, it wasn't exactly bell-shaped. All right. Questions there? If the data is not bell-shaped, we have what's called Chebyshev's theorem, or Chebyshev's inequality. And I think, did I add this to your formula sheet? This is like the one thing that is not on the
Yes.
formula sheet in the back of the book, but I think I added it on under the empirical rule. So it's saying if your data isn't bell-shaped, we can use this formula. 1 minus 1 over k squared. K is the number of standard deviations, and that would tell us our percentage of data that fell in that window. So for instance, if I wanted to use Chebyshev's, if I said, nope, that didn't look bell-shaped enough. If I wanted to use Chebyshev's theorem to approximate it, within 3 standard deviations, so it's just 1 minus 1 over k squared percent. K is the number of standard deviations. So 1 minus 1 over 3 squared. And what does that give us?
88.8 to 88.9.
We get 0.8 repeating, so that's 88.9%. So we use this when it's not bell-shaped.
This seems so much faster.
It is. I mean, it's just a straight percentage of your points that should fall in there. I'm not going to do part B, so we're just going to skip that. I think, did I put it? Okay, let's go to the very end of your slides. I put another example on here. So at the very end, I'm going to jump for a second. So suppose I gave a test with an average score of 84 and the standard deviation of 5. From the empirical rule, what percentage of scores were between 74 and 94? So we can use this paper, or this chart. We had an average of 84. What was our standard deviation? 5. So if you want to go down, you just keep subtracting 5. Go up, you add 5. That kind of gives me my numbers. This is our first standard deviation, second standard deviation, third standard deviation. Does everyone know where I'm getting these numbers? So 74 and 94. 74 and 94, isn't that just the second standard deviation?
Yes.
And empirical rule says what percent should fall within 2 standard deviations? 95%. Okay. Lower than 79. Okay, so we have to kind of think a little bit more here. There's a couple ways to do it. If this is perfect, the mean is the middle. What percent of the scores are below that? 50 are below, 50 are above. We already know in the first standard deviation that's 68%. So this little rectangle will be 34 because it's half of 68. So to get less than 79, you could just do 50 minus 34. And we get 16%. Got a score lower than 79. Okay, what percent were between 69 and 94? So that is not a set perfect, it's 3 standard deviations below, but only 2 above, right? So we can go back to those percentages. What did we say this rectangle was?
13.9.
And you could figure that out again. Does everyone remember how we figured it out last time? And what was the next rectangle?
2.35.
So I wanted between what?
69 and 94.
So we have to add up everything between 69 and 94.
97.35.
Is that okay?
On the graph on the first slide you went to today, at the end has a 0.15. Why don't we use that? On this.
Oh, I just calculated that much, but I mean, if we need to find it, we would. I just didn't have something else.
So it was, okay.
So we would use it if we needed those numbers. Okay. Above 99. So this is kind of your question as well. So above 99 is higher than my third standard deviation, right? We know that 99.7% falls within 3 standard deviations. So if you do 100 minus the 99.7, we only have 0.3% to split between the 2 ends. If you divide that by 2, you get 0.15. So this is a 0.15% right there. So above 99 would be 0.15%. So a lot of times I'm just going to ask you 2 standard deviations or 3 standard deviations, but if I start doing a combination, use those extra graphs to kind of fill in things and work from there. Last piece I wanted to talk about is the only thing we're covering out of section 3, and it's a weighted average. So basically, a weighted average, that's like your GPA. A's are worth 4 points, B's are worth 3 points, C's are worth 2 points. So if you're trying to calculate your GPA, you basically take however many A's you got times 4 points, because the weight of an A is 4. You take your B's times 3 points, because a B is worth 3. So you take the number times its weight, and then we'll divide it by the total. So if we look at an example of that. Okay, Bob goes to a by-the-weight nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate-covered peanuts, and 1.5 pounds of cashews. Raisins cost $1.25 per pound. Chocolate-covered peanuts are $3.25 per pound, and cashews are $5.40 per pound. I want the cost per pound. From my experience, it's usually the top of the fraction is okay, the bottom is not. That's where people get confused. So let's start on the top. You have to take each value times its weight. So I have 1 pound of raisins, and how much do we pay for raisins?
125.
Okay, and I'm adding this all together. I have 2 pounds of chocolate-covered peanuts. How much do we pay for chocolate-covered peanuts?
325.
Okay, I have 1.5 pounds of cashews. How much do we pay for cashews?
540.
on the bottom, we have to decide what we're dividing by. It's the total, but it always confuses people. Is it the total number of pounds or the total cost? So if you're stuck by that, look right here. The cost per pound. Okay, in a fraction, we have our numerator. The division is like the per and our denominator. So the bottom should be the total number of pounds that we have. So if we add together our pounds, we had 1 pound of raisins, 2 pounds of chocolate covered peanuts, 1.5 pounds of cashews. So we should get that it costs $3.52 per pound. So since I said cost per pound, the top of the fraction was our total cost, the bottom of the fraction were the number of pounds. Do we need to do more weighted mean questions or weighted average questions? So I really just want to give you guys time to work today. So you have all the assignments from yesterday. Remember, standard deviation, you are only doing problem 14 by hand. The rest of the standard deviation questions due on your calculator. So I think yesterday I told you you could do the first 4. Those were your standard deviations. Then we have our empirical rule and Chevy Chevs, and then some weighted average.